Similarly, we have to calculate the total weight of the walls. Okay, let's see in our plan on which grid line we have considered our beam. On the same line we have to assume our walls. Okay, so whatever these longitudinal lines and traverse lines you can see, for what you consider for the beams, same lines you have to consider for your walls too. Okay, so for that, first of all we have to calculate self weight of particular wall. When we consider self weight of the wall, we have to consider thickness of the wall. And what we have already assumed, our thickness of wall is 230 mm in 0.23 meter. Okay, and when we talk about self weight, we have to multiply it with the material density for which it makes. And we know that we generally made our walls with masonry, so the density of masonry is 20 kilonewton per meter square. So you get the value of self weight is 4.6 kilonewton per meter. Okay, same as beam, we have to multiply here the length of the walls. Okay, and as we already discussed in the portion beam, here we also have to bifurcate for the longitudinal walls and the traverse walls. As the length of the wall will be changed. Okay, so when we talk about the longitudinal walls, our total grid line distance is 4 meter, and you have to deduct the width of the column for each direction, and it will be 0.3 minus 0.3. So the wall length will be 3 meter. Okay, and same for the traverse wall, grid line distance is 4 meter, and you have to deduct the column width from the each side, and it will be 3.7 meter. See, this fundamental is same as beam calculation. Okay, so finally so I think when we calculate the total weight of the wall, okay, we have to take self weight, what is 4.6 kilonewton per meter. Then you have to multiply the length of particular wall. Here you also have to multiply the numbers, and when we talk about the longitudinal walls, we have to consider our longitudinal direction wall 1 2 3 4 5 6, and similarly in longitudinal all directions, so total 30 walls will be there. Okay, 6 multiplied by 5, and so the final value will be 469.2 kilonewton. Here also we have to determine the height as per meter height of the wall. You can see in this calculation I have not added any I have not considered any height of the wall. Okay, so we will multiply it with multiply it later. Now you just take weight of the wall in kilonewton per meter. Similarly, we just calculate this one for traverse walls, which is 4.6 self weight multiplied by 3.7 meter length, and the numbers are 4 multiplied by 7, and it will be 28. The final will be 437.9 kilonewton per meter. Let me just write so that we can't forget it. Okay, it's per meter height. Both values will be per meter height. Now let's consider for the weight of the columns. For that we have to consider how many columns we have. We have total 35 number of columns. Okay, so let me just write number of columns are 35. What is our size of column? See, it will be possible that you cannot have some same number of size for each and every column, but here I am taking general example, so it just size is for the same columns, and it is 300 by 600 mm. Okay, and we have to multiply the density of RCC. It is 25 kilonewton per meter cube. We just have to multiply all these values for the weight, or we can say self weight of the column. Let me just correct my word, self weight of the columns. Okay, because I think we are multiplying the number with that. So let me just find size is 0.3 by 0.6 in meter. Multiply by the density, multiply by 35 number, and the answer will be 157.5. Here you can also see I have not multiplied any height of column, so this value will also get in per meter height. Now let's see the calculation of live load. As we know that for the seismic weight of the building, we have to add both loads, red load plus live load. For the live load, we have to consider only some amount of percentage of actual live load acting on the load. Okay, for that, as in IS 1893 2002, there is clause, for clause number 7.3.2, it is given in page number 17 that you have to calculate live load on roof is 0. Now it is given in page number 24 in table number 8 of IS 1893 2002 for the calculation of live load on floors. In clause it is given that when you consider more than 3 kilonewton per meter square live load, you have to consider only 50% of this total live load in calculation. Okay, and as per this example, we have considered our live load is 4 kilonewton per meter square, so it should be fall in this category. So we have to take only 50%. It is 2 kilonewton per meter square. So here we have to consider only 2 kilonewton per meter square live load, okay, on the floor. So what is the size of floors, or I can say the size of total plan or the slab is 24 by 14 multiplied by 2. and the final value is 768 kilonewton. So this is the total live load on the floors. Let's add this all total dead loads and live load for roof and floor, and finally we have to calculate the seismic weight of the building. So first of all, let me explain you the lumped mass basic. What is lump mass? You can see here I already shown you here one elevation of 7-story building. As our example, we have considered 7 stories. So this is one 7-story building elevation. Okay, and the next diagram is for this particular building having considering with lump mass. What is lump mass? That we have to consider, or we have to we have to assume a story of particular a weight of particular story which is lumped at center point. Okay, for converting in this multi-story building to single degree of freedom. Okay, and that's why we have to consider only half of the story from the upper side and from the bottom side for each and every floor. So for this particular I have considered only half of the story weight. Okay, so if we have to calculate the story weight for this particular story, we have to consider only for half of the bottom story and half of the upper stories, and the only remaining portion will be the half of the top one, and that is the roof one. Okay, so for the roof structure we have to consider only half of the story of upper one portion. Let us start with adding all these values. First let's calculate dead load of roof. And if we want to find the total weight of the roof, we have to add both dead load plus live load. But as we know that the live load of the roof we used to consider is 0, as we discussed in live load portion. Okay, so for dead load of roof for particular story, okay, so we have to add all the self weight for the roof slab plus beams plus columns and plus walls. We calculated the weight of the roof slab is 2323.2 kilonewton, plus we calculate the load of the beams, and we already considered two types of beam, longitudinal beams and traverse beams. So you just put both the values, 263.9 plus the values of weight of the traverse beam is 268.05 plus. Now we have to consider here for columns. Okay, so the weight of the column we take 437.9, which is in kilonewton per meter. Okay, so here you have to multiply with the height, but as we know that for the roof section, okay, as we discuss in for the lump mass, we only have to consider the half of the story, so we have to multiply only the half height. So our height of the story is 3.5 divided by 2. Okay, and the same fundament we are using for the walls. Also in walls we have to consider two types, longitudinal walls and traverse walls. So first I should take longitudinal walls 469.2. Okay, in this you have to multiply it with the height. Okay, because this is kilonewton per meter height in unit. Okay, so the total height is 3.5 meter. Okay, but you have to deduct the depth of the beam, and our depth of the beam is 0.45, and you have to take half. Okay, so here if you want, I can just write this. This is the depth of the beam, because if we consider this is particular wall, height is 3.5, and your beam will be constructed like this. Okay, so this depth will be incorporated in the length of the wall, so we have to deduct for the particular to consider the exact length of the wall. Okay, and the same fundament used for the traverse wall. So let's calculate this also. 437.92 multiply by 3.5 minus the depth of the beam divided by 2. Okay, so you just calculate all of these values, and our final result will be 4509.4 kilonewton. Okay, so this is the value, or we can say the seismic weight of roof of the structure. Okay, now calculate seismic weight of the floor. For that, you have to add dead load plus live load both, and we already calculated live load for the floor is 768. I hope I have write the correct value. Yes, it is 768 kilonewton. Okay, now same calculation as we have discussed for the roof. Here we have to consider the floor slab weight plus beams plus columns and plus walls. Okay, so the floor slab value is something, 1 minute, 1747.2. okay, plus the longitudinal beam 263.9 plus traverse beams weight 268.06 plus columns 437.92. Here our column unit weight in kilonewton per meter, so you have to multiply your this value with one height of the column, so it is 437.92 multiplied by 3.5. Now as we discussed for the floor, we have to take half of the upper story and half of the bottom story, so eventually it will be the one total typical story, and the length of the column will be total 3.5. Similarly, we have to consider for the walls. The longitudinal wall is 469.2 seismic weight, and we have to multiply the length, and as we discussed, the length should be deduct depth of the beam. Here you don't have to divide by 2, because we have to consider half of the story from the upper portion and half of the story from the bottom portion, and eventually it will be the one story. Okay, and the 437.92 multiplied by the height of the wall is 3.5 minus the depth of the beam, and finally the value. Okay, and yes, we have to here consider the live load. It is 768 kilonewton. Okay, So let me just sum all these values, and I have final result is 6364.83 kilonewton. Okay, and we know that we have total 6 number of floors, so we have to multiply this value with 6, plus we have to add the roof value, which is 4509.4 kilonewton, to calculate the total seismic weight of the building, and the answer is 42698.2 kilonewton. Okay, so this is the final